It's my absolute pleasure to introduce the speaker this evening, who is the IMarEST 115th President, Professor Chris Hodge, OBE, and he is going to deliver the annual President's Day lecture. Chris served for 26 years in the Royal Navy, gaining a BSc degree in mechanical engineering, an MSc in electrical engineering, and a postgraduate diploma in nuclear engineering. Among other sea appointments, he served as the Marine Engineering Officer in HMS Orpheus and HMS Conqueror. Subsequently, he served in the UK MOD as the head of both the mechanical and electrical nuclear steam raising plant design authorities, and completed his naval service as the head of the Electrical Power Systems Specialist Group. He left the Royal Navy in 1998 and joined Rolls-Royce Marine, and served in various positions there before joining BMT DSL as the Chief Electrical Engineer in 2005. He has experience across the full gamut of marine engineering, including operation, maintenance, in-service support and design of systems and equipment for both surface ships and submarines. In particular, he has a significant international reputation for his breadth of knowledge and understanding of marine electrical power systems. He's particularly recognised for his work associated with the topology and application of innovative power electronic converters, the issues relating to novel torque dense propulsion motors, electrical machine windings, space harmonics, and the stability determinants of marine electrical power systems. He's published widely, he's won numerous awards, and has been invited to deliver keynote addresses in several international engineering conferences, including in Japan, China, and the USA, as well as in Europe. Chris was made an Officer of the Order of the British Empire in Her Majesty the Queen's Birthday Honours in 2015 for services to Royal Navy Engineering. He's a Chartered Engineer, a Fellow of IMarEST, a Fellow and former elected Trustee of the Royal Academy of Engineering, and an Honorary Professor of Engineering at the University of Warwick. From 2009 to 2016, he served as Chairman of the IMarEST Board of Trustees and took office earlier today as the 115th President. So I'd like to invite Chris to come and give his lecture, which is on a century of engineering education and challenges for the future. Chris.
Thank you, Jane. The first thing you should note is that I did this, or put together these slides about 6 weeks ago and then forgot to look at them again, so I think they're going to be as much a mystery to me as they will be to you, but we'll see how we get on. The other thing is, it's called A Century of Marine Engineering Training, but it actually talks about my father's, my training and my daughter's, and it actually covers 80 years. But that's all right, because part of my theme as I go through is how engineers know how to approximate. So I'm actually going to talk about the importance of engineering and why marine engineering is important. And forgive me, I'm the president of the Institute of Marine Engineering, Science and Technology, but I am an engineer, so the scientists among you, please forgive me. I do recognise your importance and your place in the Institute. We'll talk about 3 generations of training, that undertaken by my father, myself, and my daughter, the new challenge that technology has brought with it, the moral dimension to all of this, which I find significant, and I think it's important, new possibilities, and then I hope to inspire some discussion. It is, of course, all about my personal views. I'm an amateur when it comes to this. I was thinking maybe I could talk to you about the stability determinants of DC power systems, or the space harmonics of machine windings in axial flux motors, or whatever, but I didn't. So, and they're all shaking their heads, and Alan McAlinden there is busy laughing himself. Alan, calm your enthusiasm. So anyway, I came to this. This actually is formed out of the first Gordon Hodge inaugural lecture that I did when my father had his memorial lecture instituted, and I repeated it, slightly updated, in Singapore recently on the first occasion it was taken abroad. And a lot of this is in those lectures, but instead of that focus being how do you encourage the young to take up technology and engineering, this one aims to be more about how you train them once you've got them in the system. But there is certain overlap. So first of all, why is engineering important? And this is a Wikipedia definition of the built environment. The phrase built environment refers to the man-made surroundings that provide the setting for human activity ranging from the large-scale civic surroundings to the personal places. That's fair enough. The term is also now widely used to describe the interdisciplinary field of study which addresses the design, management and use of these man-made surroundings, their relationship to the human activities, and it goes on and on. The point I'm leading to, you don't need to read all that through, is that it's only at the end that you get some kind of engineering. But the truth is, engineering is everywhere around us. There's very little we can see, certainly in the built environment, that doesn't owe a debt, if not a complete debt, to engineering. So engineering is certainly important. Is it important in the marine dimension? Well, we're becoming increasingly concerned about global warming. And I suspect none of us here, least the marine scientists among us, are climate change deniers. The statistics are the same whichever way you look at it. And the cause is actually self-evident and it's obvious. It's, amongst other things, CO2 emissions, leading to a warming planet. So there's a challenge there which engineering has to solve. The scientists have done well to define it, but when we solve it, it will be the engineering challenge. So not only is it all around us, but it's the route through to our secure future. Look at the maritime sector. The International Chamber of Shipping states around 90% of world trade is carried by the international shipping industry. We've got 50,000 merchant ships trading. The world fleet is registered in 150 nations, and it's manned by over 1 million seafarers of virtually every nationality. It's big, and it constitutes quite a large part of our GDP. Now, it depends how you define what is the marine contribution to the GDP, but if you accept these figures, it's bigger than aerospace. They might take issue with that, but it's not small. So engineering is important, the marine sector is important, and it continues to be important when you look at the way merchant ship numbers have grown. If you want international trade to increase, and who wouldn't, you see an increase in the merchant fleet. So marine engineering is important. And now I'm going to talk about how 3 generations of people were trained as marine engineers, and I'll start with my father. And that's really the training of the Hodges from 1934, and he started to 2014 when my daughter started, and it starts with him. Now there's some of you here will say, that's not your dad. It is, because that's my son. And that's me, looking young, and that's my daughter. Now there is a march of technology. That is a steam reciprocating, triple expansion steam reciprocating engine that would have been known to my dad. 2,000 horsepower, about 1.5 megawatts. About the same size as one of these, which is 46,000 horsepower, 35 megawatts. That's a Marine Trent 30, MT-30. That is the type of ship my dad was on. That is the Gold Ranger. There's its statistics. I was thinking that might be my phone, but it's not. And that's the type of technology my daughter deals with. And clearly there's quite a lot of change going on. So I just want to briefly recap my father, because he does have this memorial lecture, and this is the genesis of these slides. He was a long-term servant of the Institute, a council member in 1964, continuous council and committee service, and he chaired effectively all of the main committees, and he co-chaired the RENA IMarE merger committee when we last had that as an ambition. He's a long-term lecturer and taught many, many students. The problem I have is when I do these lectures, normally a couple of them come up and say how good a lecturer he was, which just about reduces me to tears, and that's an issue. When I did this in Singapore, that happened a minute before I started to talk. When I got my daughter to give me some feedback, she said, "Dad, you're a bit nervous for the first 3 slides." I said, "That wasn't nerves." And I think he still has a lot of people around who know him. And I actually have a visual aid here when I get to that bit. It's a slide rule. How many of you here use slide rules in your training, just out of interest? And how many wished you'd done? There we go. Well done, Paddy. So, marine engineering has changed, and his training started with a classic fitter and turner apprenticeship, and that was at Phillips Son, the shipyard in Dartmouth that's now actually the yacht marina down the bottom of Sankey Steps. And when I was at Dartmouth, there was still a bit of Phillips and Son on the other side of the river. But it was labour intensive, it was brutal, and it was not for the faint-hearted. That's a typical picture of a shipyard machine shop, which he would have known well as a fitter and turner. There's an engine erection shop. There's a ship being constructed on the slip. But it wasn't just that. There was also the drawing office, which he had to spend a lot of time in. And of course, throughout it, particularly for those with any ambition, there was night school. And what we would call continuing professional development in today's terminology for him was his certificates of competency, all taken at Poplar Technical College in basically the 1950s. And that took him right up to an extra first class certificate. Now, I've seen those exams. They're crucifyingly hard. When I was at the Royal Naval Engineering College, I'm almost ashamed to admit, we knew when we were getting the answer right because a lot of the things started to cancel. It was uncanny. The questions they were presented with on their board of BOT exams were real-world design questions with no sort of giving in to the needs of the student. They were hard, and I think they were a genuine test. That's decided at the time to be equivalent to a pass degree, and it enabled people with an extra first class certificate to become chartered engineers when we first moved that up to degree level. I think it was better than that. And it was coupled, of course, with a lot of practical training. The other thing to note just in passing is when he applied to join the IMarEST, or then the Institute of Marine Engineers, that is the totality of his application. It's 3 sides of foolscap. Mostly it's typed, and he's written in longhand script in a few places, and that got him to be a member of the Institute of Marine Engineers and a chartered engineer. I don't think we can discuss it tonight, but it just strikes me we have got a bit too tied up with the route you take to get there rather than the point you actually arrive at. Now, I know that we have the ex-chairman of the Engineering Council with us. If you've handed over yet, Nigel? Not ex yet. Well, you can still give me a hard time then with some real authority. We have John Chudley here somewhere. Where are you, John? Ah, there you are. He'll be coming to see me afterwards about this. But I think we can simplify what we ask our young people to go through to prove they're ready for registration. Now, I think if you go through in the minimum time possible, you should get a proper grilling. But there must come a time in your career where a lot can be taken as accepted. And I know that a lot of the people we have in defence services are intimidated from going through for registration just because of the complexity of putting together their body of evidence. And that must be a bad thing. So, anyway, he was trained through an apprenticeship, plus other stuff as well, night school, and then the CPD of his continuing development as he worked up the ranks in the Merchant Navy. A 7-year craft apprenticeship, intensely practical. He was building ships by the end. Night school throughout, further training in ships as a junior engineer, and of course Department of Transport examinations. Now, what about me? I started in 1972. And I think that picture is taken in 1981. And I went to the Royal Naval Engineering College at Maritime, which for a young man like me was essentially heaven on earth. It was a lovely place. I don't think we'll ever see its like again, but it gave a very good practical experience as well as a very good academic training. And if you needed a test equipment, it was generally full size and probably in the hangars down the bottom of the college. If you were working in the college itself, it would be real-world equipment as well. Quite extraordinary. There was some workshop training, and we worked around all the different areas, and there was, of course, a lot of practical instruction on equipment. Frank, do you know Chadwick? There you go. Good. Hang on. Well, I did well getting that slide up there. And of course, it wasn't all work, far from it. I mean, the social life at Maritime was fantastic. The mess dinners and ladies' nights in the Great Hall still stick in my mind as some of the best events. And there was a wonderful sort of formal mess life going on. That was the posh end, the East Anteroom. You weren't allowed in there for the first 2 years. You were forced to go to the rather more scruffy West Anteroom. But it was a wonderful place to be. It was a 3-year BSc, Bachelor of Science, in Mechanical or Electrical Engineering. There was a focus on laboratory practical work in all years, a major third-year project, intensely academic, but with access to full-size naval equipment, and then master's level available as a mid-career course. And where's Martin Murphy? I'm not going to do it, Martin. I'm not going to tell my joke about you. Well, not till the end, anyway. He taught me on the advanced course, the Master of Science course in Electrical Engineering, which cross-trained me from mechanical to electrical. So, that's the intermediate bit, and then we get my daughter Rebecca, who started in 2010, and she went to the University of Manchester, and she said, one day she came home, she said, Dad, I'm going to be an engineer, I'm going to university. I said, oh, that's good. Which university have you chosen? She said, Manchester. I said, that's very good. That's a good academic and practical university, and with UMIST merged in there as well, it's better than ever. She interrupted me. She said, Dad, no. No, it's because it's a big city with lots of nightclubs. And there she went. And she was basically taught and educated in the old UMIST buildings, of which that is one. And I'll just tell a little story about her. I don't think it's unfair. They were presented with the task of working out the torque on the disc brake, and they had to do it by the 2 methods of constant pressure and constant wear. And my daughter said, what's a disc brake? Well, how could she have known? Because her exposure to technology was not what it was in my day. And I'm going to come on to that later, because I think that's quite important, how we develop an understanding of the real world and how that enables us to become engineers. I think the university missed a trick. They could have given the drawings, they could have given the parts, they could have made them build it up, bleed it, set it to work, measure it in the laboratory, and then calculate it. Just a thought. But she did the modern 4-year integrated Master of Engineering in Mechanical Engineering with a focus on laboratory work in all years, a major 3rd-year project, a 4th-year design exercise, intensely academic and challenging, and master's level units from year 3 on, but workshops for a total of 3 days over 12 weeks in the first year. So the amount of practical training is going down. But that is actually inevitable considering how technology has changed. And there is a new challenge, and it's what we've seen already. It's the fact that we don't get presented with triple expansion steam engines which you can take apart with a spanner and a bit of a rough file. And I also think that technology is moved away from what people can experience as they grow up. So what is the technology I was faced with as I grew up? Well, actually, it was my father's car, a 1950 Triumph Mayflower, a wonderful thing. But that technology wasn't far removed from the triple expansion steam engine. And working on that car gave you some kind of understanding how things work that was still relevant. If you look at the engine compartment, it was outrageously simple. You could look at that and see the parts. You can all see the radiator, the heater manifold, the inlet filter, the distributor, the spark plugs, the coil. It's all there laid out in front of you. You know how the engine works just by looking at it in the engine bay. I spent weeks grinding in those valves. That taught me a lot. But you could build it with a couple of spanners in a few hours. It wasn't difficult. You could drop the pistons out the bottom of the block. You could repair almost anything. What do we get now? That actually is, I mean, it's not the precise car, but that is the engine compartment in my current car. It doesn't exactly welcome you in. It doesn't say, come and have a play. And also, it never goes wrong. The cry at home when my dad had the Mayflower was, Dad's home, bonnet's up, because there was something else to fiddle with. But you could. You can't on these. If you're going to fix that, the first thing you need is a laptop to tell you what's gone wrong. You're not invited into the technology. Again, that's part of the challenge, but it's got worse. It's not just that we can't take the engines to bits. We've moved on. We've got the digital revolution, programmable logic controllers. We've got the revolution in power electronics. We've got the revolution in microelectronics. This has all happened in the last 20 years. What does that mean? If you put them together, you've got new technology. You've got a digital revolution. Add it all up, put that together, there it is. That's what people have to deal with today. That requires new training. Now, engineering has become much more system-focused, inevitably interdisciplinary. But there's much less need for craft training. But I wonder if there's enough. Now, I just want to divert into this, the slide rule. I brought my father's here, which, by the way, when he was at Technical College lecturing, was called Gordon's guessing stick, because he was notorious for never getting the right answer. But the best you could do with this was 3 significant figures. You rapidly learned what was important and what could be ignored. What you do now is you write down a whole string of equations, you put the numbers in, you tap it into your calculator, and you give the answer to 12 decimal figures. On the way, you've added up bits that are orders of magnitude less than other bits, and they didn't need to be taken into account, but you did. This forced you to have an understanding of scale, an expectation of the answer, and a better connection, I think, with technology. I actually would like to see universities force their students to take engineering degrees with a slide rule. I think it could only be beneficial. And I have promised that to Douglas Ward, who is going to be here tonight. I was going to hand him to him, but he's broken a bone in his foot. But you are here to witness that the slide rule turned up, even if Douglas didn't. So, academic training remains vital, but the courses have yet to catch up with the modern need for breadth. You can't do that integrated system incorporating all that microelectronics and a bit of mechanical engineering and a bit of electrical engineering without breadth. And yet, when you look at the programs offered in our universities, I took this one just immediately off the web. There were 5 in civil engineering, 10 chemical, 18 electrical, 2 were integrated mechanical and electrical, and thank heavens for that. 42 were mechanical. And that's one UK university alone. How on earth does a young man or woman coming out of secondary school with some A-levels, with a good knowledge of maths and science and a wish to be an engineer, choose which of those suits them? It's almost impossible, and frankly, they're too focused. If you want to be a power engineer, and if you want to save the world from global warming, that's what you have to be, but I bet no one's told that. Then the prospective electrical engineer can do all of those, and if you've got a particular interest in power engineering, you can do the bottom 3. Again, for me, that's too much concentration, too much narrowness, not enough breadth. And how do universities sell their product? An engineering degree is a versatile degree leading to careers in management, other professions, and in non-technical fields. Oh, by the way, careers in industry, but in engineering might be possible. Now, that's bad, but it only matters if you first get people to want to be engineers. And there's something going on there as well. This is the moral dimension. I personally think engineering is one of those things that is a vocation in not quite the religious sense of the word, but the truest sense of the word. It's the thing which will make you happy if you're allowed to do it. And because we have this disconnection with technology, and I'll come back to that, but because we no longer give children the chance to play with engineering, they no longer know they have that talent. And I think that is a great shame, because it removes us of talented individuals in the engineering profession, and it stops them being fully fulfilled. That is the moral dimension. And there is some evidence that we're getting it completely wrong. Intelligence dimming, disturbing evidence of a decline in youngsters' brain power. This is in The Economist from 2008. They've talked about cognitive intelligence, a general mental capacity that involves reasoning, planning, problem-solving, abstract thought, comprehension of complex ideas, ability to learn quickly and from experience. And they further said it is not merely book learning, a narrow academic skill, or test-taking smarts. What it actually is, of course, and this is me now, not The Economist, it's the stuff of engineers. So how do we enable kids, children, to develop cognitive intelligence? Well, they went on. In 1976, more boys than girls did well in cognitive intelligence tests. A fact the researchers put down to boys roaming further out of doors and playing more with tools and mechanical toys. Both sexes now do worse than before, but boys' scores have fallen more, suggesting that a decline in outdoor and hands-on play has slowed cognitive development in both sexes. Britain's unusually early start to formal education may make things worse, as infants are diverted from useful activities such as making sandcastles and playing with water into unhelpful ones such as holding a pen and forming letters. I really couldn't have done that. That's just wonderful and something to think about. Now this is a video straight off the internet.
Och det tekniska designingen och Martin som börjar bli färdig med midjen. Det är bra. Har du något batteri till kontkopi? Ja, jag måste extra batteri då. Henrik! Köp den ner, det var ut! Köp Henrik!
That's the translation. And of course it's fantasy, but there's something in it. You know, there are a lot more people who can be engineers and never get to be them. And that's what we've got to get right. Here's another one, the knack.
Little Dilbert, he's not like other kids.
What do you mean?
Yesterday, I left him alone for a minute, and he disassembled the TV, our clock, and the stereo.
That's perfectly normal. Kids take things apart.
Oh. The part that worries me is he used the components to build a ham radio set.
Oh dear.
Is that bad?
Normally I'd want to run an EEG on him, but the machine isn't working. It's worse than I feared.
What is it?
I'm afraid your son has the knack.
The knack?
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical, and utter social ineptitude.
Can he lead a normal life?
No. He'll be an engineer.
No!
There.
I love it. But how does a young person realize they have the knack? Engineering makes complexity straightforward. That's its point. It also makes the dangerous safe. It insulates the user from technology. And that's not a good thing. Let's just think back about computing, this argument, are we digital immigrants or natives? It really started in the 1980s. I know there was computing going on before, but when it became sort of mass market stuff, it was the 1980s. And this is the BBC B. It's quite a posh one. It's got a decent computer monitor. Most people ran them on their televisions. But if you open that up, it was completely accessible. There was nothing you couldn't play with. There's nothing. It's a bit like that engine in the Triumph Mayflower. You could point to it and say that's the RAM. You could point to it and say that's the USB, well, not USB, but that's the serial connector. It was all there. And it was documented. You could get books that told you which bit to play with and which bit to change. It was full of analog to digital and digital to analog converters. It could interface with the real world. It sucked you in. It made you play with it. It made you want to use it. What's the modern equivalent? How are modern young people exposed to this sort of technology that's now ruling our world? That's it. That's the equivalent thing. Again, it's like the car. It doesn't say to you, come inside, let's have a play. You can use the applications, and I think that's what most of them think it's all about. But inside there is a miracle, and it's an engineering miracle. And it's one they're not allowed to appreciate, and it's one that therefore doesn't make them think, I could do that. So now I'm going to talk a bit to Ollie Simmons, who sat down over there. He gave a magnificent after-dinner reply on behalf of the guests to an earlier IMarEST dinner when Nigel was president, and he focused heavily on Lego, and I told him afterwards that was the end of our relationship because clearly the right answer is Meccano. But I have to admit, in today's world, that might not be right. Maybe neither's right. I think we need something else. That's good for triple expansion steam reciprocating engines and some cognitive intelligence, but we need people to deal with this. And so what's good for highly integrated modular systems? What should our kids be playing with? Well, that's it. It's called an Arduino. It's a microcontroller, and it will run programs which you can program through a USB link from your PC, and it will interface to all sorts of things in the real world, through all of that plethora of pins and connectors you see on there. And that's the small one, there's bigger ones. So there's a Arduino running a sort of demonstration board with various types of serial communication. There it is running a little sort of robot rover. There it is running a robot arm. They've even put it in new form factors, such you can make really odd things with it, but that's run by an Arduino. And this is built around Arduinos, and it's not for kids. It's a cocktail maker, in case you're worried. This became quite a cult on the internet, and he was submerged in offers to buy it. I don't know what happened, but he's got a small fortune. He sold all the ones he was asked to provide. But run off an Arduino. There you go. So, what are the new possibilities to train our young once they've identified they've got some kind of talent because we've managed to give them all this sort of training that includes cognitive intelligence, and they have somehow engaged with technology even though it's all hidden from them? Well, I think there's apprenticeships. And this is a really good development. And it's not just because my dad was an apprentice. I think what we're doing now with apprentices are entirely different, but entirely fit for the modern world. And this information is provided by Professor John Chudley, who I can't see in the audience. Oh, there, oh, John, you're hiding at the back, because you know what's coming next, don't you? Yes, he's nodding. This is John and his early engagement with technology. But it's a serious point. John had exposure to technology that was understandable. And he developed a love for, what's that kind of motorbike racing called, John? Motocross. And there he is with his brother on bikes they would basically maintain, repair, tune themselves. Good engagement with technology. And in John's view, and he has a lot of experience in this area of how professions work and how we need to train them for him, but he's got this idea of a profession being a sort of truncated triangle, because as you move up through your career, you become slightly more less numerous. And that sort of has levels of academic achievement, and I've shown from 2 to 7, there's actually a 1 and an 8, which will be obvious as we see what they are. Those levels broadly equate here, so level 2 is a good GCSE, level 7 is an MEng, level 8 is a PhD, and level 1 is GCSE but D to F. And the idea is that you move up that way throughout your career. And the key thing is, it's throughout your career. It doesn't have to all be at the start. That's where our current levels of registration sit, and I hope Nigel will forgive me if I say I think that's better, but I'm not going to leave it up there for too long, because that's where it actually sits. But the point from John is the apprenticeships cover that full scope of development throughout your career. Another way to draw that is there's the academic levels at the bottom, and I shouldn't say academic, but they're the sort of competence levels. John's nodding, thank you, John, I got that bit right. Competence levels from 4 to 7 through your career, and professional bodies deal with standards, registration and CPD, and the employer and industry worries about the competence. And I guess traditionally we did our academic education right at the front and then forgot about it. That's wasteful. There is obviously a clear straight line through, ending up with an MEng. But that's not the only way, and if people drop off along that path, it's very wasteful not to allow them back on it to further develop their careers if they have the aptitude. So that might be a better way to do it throughout life. Now, the point from John is that academic education, that competence training, is part of the apprenticeship, and it covers both the professional bodies, the employer and industry, the person himself throughout his career. And I think that is a very good model. It's not the only way you can do it, but it's a way that would suit an awful lot of people who perhaps have a more practical bias and need to sort of develop throughout their career rather than just immediately at the start of it. Another new possibility is the Marine Learning Alliance, the MLA College, and this is its promotional video. And the important point is the MLA is flexible. You access it when you need it, and it helps you throughout your career, and it's blended e-learning, and it's distance learning, and it's suited to you, and it's available throughout your career. And I think it's a wonderful thing that will go alongside the apprenticeships John's been dealing with and help a lot of people develop their career to everyone's benefit, including theirs. These are the courses that it currently does. I think there's more scope. This is a real initiative, and I should have mentioned it is, of course, a wholly owned subsidiary of IMarEST. And I think it is simply brilliant. It could fill in the gaps in the requirements for your registration. It can cross-train you to another area of technology. It can increase your depth of knowledge. It can help in all sorts of ways, and it's flexible and suitable to you. So, now I'm going to come on to the discussion points, but actually you can ignore these if you want, but they are just things I think are worth thinking about. It's not all about maths and physics. Practical needs to be emphasised as well. We have had a reduction in the amount of practical training as you go through these integrated Master of Engineering courses. That's sad. I understand why, because life's short and there's not much time, but we need balance. And I think engineering is inherently a practical subject. It is about approximation. It is about getting the answer to whatever, it's not just about the 20th decimal place or the most impressive differential equation. There's more to it. And I really do mean it. Slide rules. We should put those back in colleges. We need to get young people to be more exposed to technology. I think, Edward I mandated archery training at the butts every Sunday after church. We should at least put things like this back in the school curriculum. Meccano, Lego, makers clubs, Raspberry Pis, Arduinos. Get the ones who want to make something, making something. Because the other thing I feel very strongly, if you don't actually want to make something, you probably don't want to be an engineer. But there's very few opportunities for youngsters to make stuff. But this is a help. Education should be available throughout life. I think we're all too rich a resource to enable us to allow us to be thrown, out of education and not allowed back in. We all have different routes that should all be supported. everyone joining the engineering profession should be able to see a route through that can take them to chartered engineer. And again, the IMarEST MLA can help. Apprenticeships should attract the more practically minded, but there's still scope, obviously, for traditional degree education, but with more practical experience. Distance learning will help in the workplace, but accredited and recognised. And experiential learning needs to be recognised. It is already, but I think it could be better recognised. Why ask a mid-career design engineer to undertake a master's project if he wants to get the distance learning MEng? Is that necessary? Now, this is where I get really contentious. I think we should have a BEng standing on its own, still 4 years, and this is where all the educationists get shocked, because you can't have an undergraduate degree that takes 4 years, but this is my dream. A 4-year undergraduate degree, very broad, combining mechanical, electrical, civil and chemical, and then another MEng postgraduate degree, specialist, and ideally taken sometime after the BEng. What do you think? Because that is the end. I'm delighted to have spoken to you. I hope you enjoyed it, and I, of course, will take questions. Thank you very much. Standing to attention, Jane. Yes, I was beginning to slide down. Richard.
I think probably you didn't sell enough some good stuff that's going on, like STEM ambassadors. You didn't mention things like the Big Bang Fair and all the good things going on in schools with the BBC microbit and stuff like that. So I was a little bit disappointed that you painted rather more on the bleak side and didn't mention some of the very good positive things that are also going on, you know, with STEM ambassadors and things like that, and the work that they do in secondary schools.
I agree. Why didn't I do it? Well, I think I wanted to be a bit shocking. And there's more than you mentioned. I know you only took a few. And there is a great drive to get people into schools and make them sort of aware of what engineering does. But, you know, that's 1 or 2 days a month, if that. We need more exposure earlier, in my view, because we tend to do it in the secondary schools. I think it could be too late by then. I think we need to get people attaching to technology much earlier down. But I agree with you. There's a lot going on that is very good. And actually a lot of it, of course, that depends on the enthusiasm and contribution from the members of our institutes. So that's good.
Chris, it's Paddy. Oh, sounds a bit loud. Paddy Parvin. Just teasing out that point, you've also almost practically answered the question in the process of answering the previous one. I can remember doing handwork at school, in primary school, which was 2 periods of 2 hours a week where you got to do stuff, mixing plaster of Paris, building paper mache lighthouses and getting them to flash. Do you know if that stuff is gone, or is that where we're failing? And the second part of that question is, do we then allow the teachers the latitude to turn around to people and say, actually, you've got a potential to be an engineer, and push them away from what might be a traditional reading, writing and arithmetic sort of approach, heaving up on the technology side?
There is a new subject, is it called design technology? But it doesn't tend to be what we would have remembered as woodwork followed by metalwork when we're a little bit older. I think we need more of the traditional filing and drilling and nailing, quite honestly. Yeah.
Chris, thank you very much for an absolutely wonderful presentation, full of humour and some really good stuff. I sit in the advisory board of the University of Aberdeen, and for a number of years now I have been trying to convince them that they should scrap the MEng and go back to the BEng and follow that up with an MSc and one of, I think they've 11 specialist courses where they teach at master's degree. And it's so nice to see that someone else actually agrees with me, because not many do. So what can we as an institute do to promote that? Because I think it's exactly the right way ahead. It's also interesting that I had quite a long conversation with one of our graduates just last week, who actually did, I think, an HNC as part of his 6th-year studies, and then went to university. I told him that was an improvement, but what he should have done is an apprenticeship first, and then an HNC or an HND, then a degree course. And, you know, how can you get better than that? So what can we as an institute do to try and promote that, to get away from the current situation?
Yeah, there are many, many routes through to being a professional chartered engineer. Some of them are more awkward than others. What we should be doing as a profession is trying to remove that awkwardness, because they're all, must be all, of equal value. And I personally think apprenticeships are a good thing. I'd like to see much, much more of them. John, would you like to make a comment?
I'm not sure I was going to ask a question in a minute, but no, I agree with you. I think there has to be a promotion of many routes, not just one route. You know, the obsession, and you know, in this country, it's also the way the government fund education. They fund age, not stage. 16, you must do A-levels. 18, you must do a degree, rather than perhaps those of us that did apprenticeships. I wasn't level 3 until I was 21. I wasn't ready to do a degree until I was 21. Whereas now, we're all programmed that everyone must go and do a degree at 18, and you haven't got any life experience to take into that degree to help you. So that's my comment. Question? I'll be quick. First of all, watching that, if my parents were still alive, I'd sue them from a health and safety point of view. Just thinking about design and thinking about the one box mentality. I mean, it happened a while ago. Steve Jobs that probably led that from a computing point of view. You know, Wozniak wanted loads of ports, and Steve Jobs wanted one port and lock the box, and you can't get into it. So it's quite interesting. But from a point of view, I was thinking about who's actually going to make the things. You showed all of the electronics, but in actual fact, one thing that wasn't mentioned was 3D printers. So ultimately, you're saying we all have to go and use a hammer and nail, etc., etc. But at the end of the day, I'll have a 3D printer in my house that's going to manufacture anything I want.
I agree. I think 3D printers are wonderful, and the people I admire most are the ones who build their own. A home-brewed, home-programmed 3D printer. A great connection with the technology. But I do think, I said it, but I think the important point I'm sort of trying to make with respect to engagement with the technology is that engineering is a victim of its own success. It's made the complicated too simple, and it's made the dangerous too safe, and it's prevented us actually engaging with it. As I said, it doesn't welcome you in anymore, and that's the shame.
Nigel Guild, past president and chairman of the Engineering Council. It's not so much a question, but it is a comment and a bit of an answer. It might surprise you that at a board meeting of the Engineering Council this afternoon, in the discussion period, nearly everything you mentioned was chatted about, and the minds are open to it. It takes a long time to implement. And if I can answer Andrew Gilchrist's question, what can we as an institute do about it? The answer is contribute to the Engineering Council. The Engineering Council is owned by the institutes, and the ones who get in there and talk help shape opinion. What holds you back is not the staff of the Engineering Council, it's the other institutes. Work out who they are and work on them. But the answer to the question is contribute. We already do. We punch above our weight as an institute, and we should carry on doing that and do more of it.
Peter Noble, Vice President of the Institute. I am in violent agreement with just about everything you said. It was a very good thing. But I think one of the challenges we have in response to what we need to do is certainly we need to go ahead with the comment of getting the STEM programs done early. But the biggest problem we have is the public don't respect engineers. And I quote often von Karman quote that says, scientists discover, engineers create. But I'm still looking for a headline that has engineering and creating in the same thing. So I think that's where the institute can do it. We need to elevate that. I was born and educated here. I had an apprenticeship in a Clyde shipyard when we still built them there. But I didn't finish the apprenticeship because the shipyard closed before I finished my apprenticeship. I've been in North America for 50 years. The reason I enjoy living in Houston, it's not a pleasant place, but engineers have status. Because the oil and gas industry, NASA, the biomedical thing, when I say I'm an engineer there, I'm proud to say it and people do it. Unless the parents of the kids that are in school now, unless they see value in engineering, they're going to push people to be lawyers and doctors and other things. So that's where the institution can do. We need to elevate the profession of engineering above that. All the other things are important too, but that's through the institutions where I think we can create most value.
Thank you, Kennison. IMarEST Council Rep from Malaysia. Couldn't agree more with your comments and the recommendations on the training that is more appropriate for engineers in the future. But maybe IMarEST could do something to further improve the type of education and training for marine engineers, especially. What I've observed is with the recent, well, not so recent, with the STCW revision that was made, it wasn't really upscaling the requirements, but it was more of downscaling, I felt. Just to give you an example, not so much for the marine engineers side, for the deck side, they were even looking at removing the requirements for competency on celestial navigation, so what more for the engineers? I think they were emphasizing a lot more on management and leadership competences than upskilling the engineers' the competence themselves. The period of training had been reduced. Used to be 4 years where you attend 3 years in the college, 1 year at sea, but now within 3 years, you would still qualify for class 4. So maybe IMarEST could try to gain consultative status with the IMO for STCW or human element training, and rather than observer status, so that you could bring in more improvements in the STCW moving forward. Thank you.
Good evening. Bob Hill, long past president. Thank you, Chris, very much. At least as good as I expected and more. It has always amazed me that in education you can't use the word engineering until after the age of 17 and a half. Many people by then have been engineers for a long, long time, usually at home or as a hobby. I believe there should be an A-level. You can't use the word engineering. So let us say an A-level called How Things Work. The trouble is, you wouldn't have any teachers who could teach it.
Only an ex-president of Sir Robert's seniority could get away with that, but I'm glad he did. Thank you, Sir Robert.
Liam Doyle, council member, Cork. Just a point, Chris. In Ireland, for instance, the degree course is a 4-year course, and in a lot of universities, what they do is in the first year they don't specialise. They do civil, mechanical, electrical, and it's only in the second year to specialise. And in the last 2 years now, the Engineers Ireland have brought out that you must have a master's degree to go on the direct route to chartered. In other words, it's a 5-year course now. So it's 4 years as a PhD and it's a 1-year master's on top of that. before you can go forward to chartered.
Thank you. Jane Pillay, former president of the Southern Joint Branch. May bring a few tears to Chris. I enjoyed your talk. It was different. I was expecting something else, but it was different, and I enjoyed it. I was one of your dad's students at Poplar. He inspired me and many others. I did most of my tickets at Poplar, including extras, motor, and steam. Got me into education. I've taught in various colleges, including the British Army. What I find is missing with engineers, they tend not to mentor and give guidance. That is the missing aspect. I go down to schools and colleges and motivate students. So more engineers should do that, even on board ship. The engineers tend not to help the junior engineers, and basically they've got to change their attitudes.
I think seniors mentoring juniors is the most natural thing in the world, and it should be encouraged because it is extraordinarily valuable. They're all thirsty.